Hi there, welcome to this lecture series on matrix algebra. This is lecture 13, part 2. Here we continue our discussion on inner products, and in particular, after covering the Cauchy-Schwarz inequality and triangular inequality in part 1, we will talk about angles between two vectors, orthogonal vectors, and the famous Pythagoras Theorem. Okay, let's get started. Okay, so let's first recall the two theorems that we proved. And the first one is the Cauchy-Schwarz. It's an inequality. It says that if you have an inner product on a vector space, then the inner product of two vectors, taking their absolute value, is less than equal to the product of the inner product of each of the vector. And the second one is the triangle inequality. It basically says the length of one side of the triangle and is less than the sum of the other two sides. So if you have v and w as two vectors and then consider the origin as a zero vector, this inequality simply says that the length of this side is less than or equal to the sum of the length of this side plus this side. Okay, so now we defined a thing we called an angle between two vectors. If these are vector spaces of vectors in Rn, and that will be the actual angle between them. And later we see this can also be defined in a more general setting. Okay, so angle theta is an angle between 0 and pi, and then is defined by this identity. Cosine of theta equals inner product between v and w divided by the norm of v and the norm of w. So we know that cosine is a quantity that takes value between 0 and 1. And how about this right-hand side here? Well, recall the Cauchy-Schwarz inequality. This basically says that the numerator here, the value of it is less than the denominator. Therefore, this quantity will be less than 1. Okay, so this angle theta is well defined on the interval from 0 to pi. And then, after defining the angle, then we can also find two vectors that are perpendicular, also called orthogonal to each other. That is, if they form a right angle. So, at the right angle, pi over 2, cosine of that is 0. So, which leads to the following definition. We will say that two vectors are orthogonal if the v dot w is 0. So this will lead to the cosine theta is 0, and therefore the angle theta is the right angle. Okay, so now let's cover this kind of a version of Pythagoras theorem, basically the same, but we write it in terms of vectors in vector space. So if the two vectors v and w are orthogonal, then we have this relation. V minus w square, the norm square, equals the norm square of v plus the norm square of w. So this basically says if you consider the triangle formed between v and w and the point, the origin, then that means the third side's square equals the sum of the square of the two sides next to the origin there. And therefore, if this is a right angle, then you have a right triangle and you have the Pythagoras theorem. Okay, so we can do a quick proof of this, similar actually much simpler proof than what we did for the Cauchy-Schwarz inequality. So, okay, let's start from the left-hand side and try to reach the right-hand side. So v minus w norm squared, and this equals the inner product of this vector with itself. And now we're going to expand this vector. So we distribute v dot v will be v norm square, w dot w will be w norm square, and then there's the term w dot v and the term v dot w, which is the same. So it's just 2 times v dot w. And now we use the property that v dot w is 0. So this guy is 0. So removing that term, which is 0, then we just have v norm square plus w norm square, okay, which is the Pythagoras theorem. Okay, so let's take some examples computing the angle of 2 vectors using inner product and the definition of it. So let's have 2 vectors v and w given as is. It's all just 1s and 0s. And then we can do the inner product, which is element-wise multiplication, and then add them up. So you get 1, 1, 0, 1, and you add up, it's 3. Okay, so let's compute the angle by computing the cosine. So the cosine theta can be computed with the formula, and v dot w over norm of v times norm of w. So this we just computed is 3. And then to compute the norm of v, you would square all the elements and add up, which is 4, and you take square root. And the same, the norm of w will be square all the elements, add up, and you get 3, and so you get square root of 3. So square root of 4 is just 2, and this over that and is just square root of 3. So we see that cosine theta is square root 3 over 2, and then we recognize that for this value of cosine, the theta is 30 degrees, or you can write in radians, that's pi over 6. Okay, so let's take another example with the 2 vectors v and w. This is in R2, and these actually are perpendicular. And we can easily verify that claim by calculating the inner product. That will be element-wise multiplication. You get -4, and you get 4, and you add them up, and it's 0. Okay, so the 2 vectors are perpendicular. Okay, and then we can also take the chance to verify the Pythagoras theorem. So let's first compute v minus w and the norm of it. So what's v minus w? And okay, that will be 1 minus -4, so you get 5 and the 3. So that will be 5 square plus 3 square. And you add them up, it's 34. And then now we can compute the right-hand side of the Pythagoras theorem, that is the norm of v square plus the norm of w square. So okay, let's calculate the norm of v square, which is square of each element and add up, so it's that one. And then for w is the same, square of each element, and then we add up. So this is 1 square, 4 squares is 16 plus 1, so it's 17, and this is also 17, and we get 34. And then we verify the Pythagoras theorem because they equal to each other. Okay, so let's extend the definition of inner product into the space of all continuous functions beyond just the space of vectors. Okay, so let's define continuous functions defined on the interval from 0 to pi, and then we consider this computation as the inner product. So given a function f and g, both continuous, defined on the interval from 0 to pi, and this notation here, this bracket with fg, it denotes the inner product. So it will be defined as the integral from 0 to pi of fx times gx dx. So you multiply these two functions and then you integrate it over the interval 0 to pi. Okay. So let's take two functions. Let's say f is 1. It's a function identically equal 1. And then g is sine x. And let's try to compute the angle between these two functions with respect to this definition of the inner product. Okay, so it's basically repeating the whole thing but using this new form of inner product. So recall the formula. Cosine theta now would be the inner product of f and g divided by the norm of f and the norm of g. Okay, let's compute each of these three quantities. So the inner product of f and g will be the integral from 0 to pi of 1 times sine x dx. Okay. And then you can work out and you will get 2. And then let's compute the norm. We can compute the square of the norm first, and then we take square root, and which is the inner product of f with itself. And then f is just 1. 1 times 1 is just 1. And then integral of 1 over 0 to pi is pi. So the third one is the norm of g. Let's compute the square. So it's g in the inner product with g, which is the inner product of sine square of x. And then we know this is pi over 2. Okay, now we're ready to compute the cosine of theta with this formula. And then we just plug in the values we have. 2 here, and this we'll have to take square root. And this one here we also have to take square root. And then you plug in the value of pi and then the value of square root of 2. You get approximately 0.9. And you can compute the inverse of cosine, and you find out this angle is about 25 degrees or 0.45 radians. Okay, so the following example is exploring the concept of perpendicular elements in the space, and the space here is a vector space of all continuous functions, and then the version of the Pythagoras theorem. Okay, so we consider again the same space, continuous function of a function defined on the interval from 0 to pi, and let's consider two specific functions where f is sine x and g is cosine x. And we want to show that with the definition of the inner product that we have defined on the previous slides, these two functions are perpendicular. And we will verify that version of the Pythagoras theorem. Okay, so to show they're perpendicular, we just need to calculate the inner product and to find that they're 0. So inner product of f and g will be the integral of sine x times cosine x dx. Right. So use your favorite tool from your calculus course. You will find out that it's 0. And also you can use the trig identity. So sine x times cosine x is sine 2x and a half. And sine 2x is a periodic function with period pi. So from 0 to pi, this function here goes through a whole period, and then the integral will be capturing all the positive part and the negative part, and they exactly equal each other, and it cancels, so it's 0. Okay, so let's verify the Pythagoras theorem, and let's compute the norm of the f and g, and in fact the norm square. So the norm square will be the integral of f square for f. So f is sine, so we'll be computing integral from 0 to pi of sine squared dx. Okay, and this is pi over 2. And then for g, and you will just have cosine here. And then this integral is the same as that integral in the end, so it's also pi over 2. Maybe I can say a few words about how to compute this integral and that integral. So since they're written now side by side so conveniently, we can first make an observation that the integral of this function sine square from 0 to pi equal to the integral from the cosine square from 0 to pi, because cosine and the sine, they're just an angle shifted by pi over 2. So the positive parts here and the negative parts without square, they have the same area. And then you put square on it, then they all flip to become positive sides, but then they're exactly the same. So now you can consider the integral from 0 to pi of sine square x plus cosine square x, which is 1 by the trig identity. So, and that integral will be pi minus 0, so pi. So the sum of these two is pi, and then each of them equal to each other, and then each will get pi over 2 as the result. Okay, so just some additional hint of how to calculate these trig integrals. Okay, so now let's compute the f plus g, the other side of the triangular in the Pythagoras theorem. So f plus g square, what does that equal to? Well, that's integral of that of this quantity. And one can expand that to get cosine square x plus sine square x plus 2 times sine x and cosine x. And we split the integral up, and this is the first part and this is the second part. And then here use the identity that cosine square plus sine square is 1. You get just pi minus 0. And this one here, we will use the property that this function f and g is orthogonal. We just verify that equals 0. So that's 0. So I get pi plus 0, which is pi, which we see that is exactly this quantity plus that quantity. So it's norm of f square plus norm of g square. Okay, so this equal that is the Pythagoras theorem. Okay, an important remark we want to make here is that the angle of between the two elements, they depend on the inner product we are using. Okay, so let's see. We consider another example, and also the space of all continuous functions. Then now we define the interval smaller. It's from 0 to pi over 2. And the inner product is the integral from 0 to pi over 2 of f and g. And then with this inner product, we see that the two functions f is sine x and g is cosine x is now actually not perpendicular. Well, we can easily verify if they're perpendicular or not by computing the inner product. So the inner product now is the integral from 0 to pi over 2 sine x times cosine x. Okay, so whichever way you choose to compute this integral, and one way would be to consider a variable change, to consider z is sine x, and rewrite this interval as and the integration here as integrating of z dz, and then we'll integrate from 0 to 1, and then you see you get 1 over 2 as the result, and that is not 0. Now we can also compute the angle between these two functions by using the formula, and then we need to calculate the norm of f and the norm of g. So let's calculate the norm of f square of that, and then you get pi over 4, and the norm of g is integrating cosine square, you get pi over 4. And these two integrals can be worked out in the same way as the trick I mentioned on the previous slide. Okay, so let's calculate the cosine of theta by this formula. And we put in the number, and this number here, and then the f norm times g norm, and that's these. It's the same as these two, right? So this times this takes square root, it's just pi over 4, and you work out the number, you get approximately this number, and you can take the inverse of cosine and find the angle. It's approximately 50 degrees or 0.88 radians. So it's not a right angle between them. Okay, so that's all for this lecture, and I hope you enjoyed it. So next lecture we will be using this concept of perpendicular vectors that's introduced here, and we learned it here, and we will use it to do something called perpendicular projection. Okay, so I hope you enjoyed this one, and I'll see you next time.